Aim of the experiment: to show that acids, bases, and salts are electrolytes. Theory: an electrolyte is a compound that, in solution or in the molten state, conducts an electric current and is simultaneously decomposed by it. The current in electrolytes is carried by the ions and not by the electrons, as in metals. Electrolytes may be acid, bases, or salts. In this experiment, we shall observe it by means of continuity test in an electric circuit that contains either an acid or a base or a salt solution as part of it. Materials required: hydrochloric acid, sodium hydroxide flakes, sodium chloride, distilled water, a 100 ml graduated cylinder, 4 beakers of 250 ml capacities, 3 to 5 dry cells of 1.5 volts each with a cell holder or a 6-volt battery or a battery eliminator, a 6-volt torch bulb or LED bulb, a large rubber cork, 2 narrow and long polished iron nails, a one-way plug key, connecting copper wires, and a piece of sandpaper. Procedure: prepare a circuit using different components like dry cells, torch bulb or LED bulbs, connecting wires, iron nails, and a plug key as shown here. Test the continuity of the circuit to make sure all the wire connection points are tight and working. To do this, join the 2 iron nail electrodes using a small length of copper connecting wire as shown here. Then insert the key into the plug. If the bulb glows, that means the circuit is working fine. Leave this setup aside. Now take the 4 beakers and add 100 to 150 milliliters of distilled water to each beaker. Label them as beakers A, B, C, and D respectively. In beaker A, prepare a dilute acid solution by adding about 5 to 10 drops of concentrated hydrochloric acid. In beaker B, prepare a basic or alkaline solution by adding about 100 milligrams of solid sodium hydroxide. For beaker C, prepare a salt solution by adding about 2 to 3 grams of sodium chloride crystals. Do not add anything in the distilled water in beaker D. Now, take the circuit setup and check to see if the circuit is indeed not yet complete. To do this, insert the key into the plug. If the bulb does not glow, it means the circuit is incomplete and is ready to be used for the experiment. Remove the key from the plug again. To begin the experiment, first take the beaker D containing distilled water alone and carefully introduce the rubber cork such that the 2 iron nails fixed to the cork are partially submerged in the distilled water. Insert the key into the plug. Check if the bulb lights up or doesn't. Record your observation. Remove the key from the plug and remove the electrodes from the beaker. Next, take the beaker A containing the dilute acid solution. Repeat the same continuity test by partially immersing the iron nail electrodes into the acid in the beaker. Insert the key into the plug. Record your observation. Remove the key from the plug. Rinse the electrodes and the rubber cork thoroughly with distilled water. Repeat the same test with beakers C and D. Record your observations. Make sure to remove the key from the plug before immersing the electrodes into the test solution and also after the test is performed. Also make sure to thoroughly rinse the electrodes before they go into the next test solution. Observations. At the end of the experiment, it can be observed that the bulb glows when the circuit is immersed into the acid, the base, and the salt solutions. The bulb, however, do not light up when the electrodes are immersed into distilled water. Results and discussion. Electrolytes such as hydrochloric acid, sodium hydroxide, and sodium chloride, when dissolved in an aqueous medium, dissociate into their corresponding ionic entities, which are charged particles capable of conducting electricity. The ionic dissociation of these electrolytes can be represented by the equations shown here. When the electrodes in an incomplete or open circuit are immersed into an electrolyte solution, the ions contained in the electrolyte are capable of transferring electricity across the electrodes, thereby completing the circuit. The creation of a complete or closed circuit is detected by the glowing of the bulb contained in the circuit. In our experiment, we saw that the bulb glows in all instances where the circuit electrodes are immersed into any one of the three example electrolyte solutions used. The bulb, however, failed to glow when the electrodes were immersed in pure distilled water. This is because there are no dissolved ions present in distilled water that could complete the circuit. Pure water is thus considered as a non-electrolyte substance. This is also the very reason why we add a few to several drops of an acid to water when performing the experiment on electrolysis of water.